So in this section, we kind of combine everything that we've done. We've combined greatest common factor. We also combine this with some special cases. So my first step is always going to be to look for that common factor. And when I look at this one, I'm going to look at both the numbers and the variables. And so you can see that, of course, 5 is in common. I can also pull out one of my x's and one of my a's. And I cannot take any of the y's. Once I do that, I'm just dividing. 5 divided by 5 is 1. I took out the a. I took one of my x's. 5 divided by 5 again is 1. A, I took out x, I took out, and I have the y to the 4th. So at this point, I'm actually not done. I need to see if anything else can factor. And this is a special case. Remember, when you have two perfect squares, it is a special case if they are being subtracted. And you know if a variable is a perfect square by the exponent. If we have an even exponent, then it is a perfect square. We just cut it in half. And so I'm going to leave this 5a to the x out here. And I'm going to do the square root of each of these, plus and minus. So the square root of x to the 4th, just cut that exponent in half. That would be x squared plus y squared. And x squared minus y squared. Am I done? I'm not done. I still have perfect squares being subtracted in this one. So I can actually factor this one again. I have the 5a to the x. Why can't this one factor? It's addition, right? Perfect squares can only be factored if they are being subtracted here. So I'm going to leave this one alone. This can factor. The square root of x squared is just x. The square root of y squared is just y. And I have x plus y, x minus y. And this is factoring completely. And so we're actually combining, taking out a common factor and then using some of our special cases to continue to factor. So anytime you have a higher exponent, like a 4 or a 6 or something like that, then when you factor, you want to see if possibly you have perfect squares that you need to keep going with. All right? So let's try one of them. Take out your common factor first and then see if you can do anything with what's left. So we're used to trinomials, but we're used to it being an x squared and an x, not an x to the 4th and an x squared. As long as this one in the middle is half of that one, then you're going to be fine factoring it just like you would. So I'm going to look for factors of 8 that add up to give me a negative 9. What are they? Factors of 8 that add up to give me 9. 1 and 8, right? So I'm going to say, instead of x here, I'm going to cut that exponent in half. I'm going to say x squared, and I'm going to say minus 1, and x squared minus 8. You can check it. Negative 1 times negative 8 is positive 8. Negative 1 plus negative 8 is negative 9. However, I can keep going. This is a perfect square, but 8 is not. So this is as factored as we can get with this one. However, this is two perfect squares. How do I factor this? What's the square root of x squared? What's the square root of 1? 1. So I'm just going to say x plus 1, x minus 1. This is already as factors as we can get it. So that is my factored completely right there. So I am looking for factors of 1 that add up to 2. So I know I'm going to have a +1 and a +1, because if I multiply 1 and 1, I get 1. If I add those, I get 2, right? When I have a higher degree, I just cut it in half. So I'm just going to say 10 divided by 2 is going to give me what this exponent is. All right? And you can check it by foiling. So if I say m to the 5th times n to the 5th, when I multiply like bases, what do I do with those exponents? You add them. So this becomes m to the 10th, 1 times m to the 5th, 1 times m to the 5th, and 1 times 1. And so you can see that even if I FOIL it, I'm going to get the same thing that I started with. This is just another way to write that. Those are the same things. This is not factored. This is not a factored version of that. This is just another way to write it. This happened to be a special case, a perfect square trinomial. So just like we've done in the past, anytime you have 4 terms, you're going to want to factor by grouping. So I am just going to group the first 2. I'm going to group the second 2. I grouped behind a plus sign, so I don't need to change anything. All right? I'm going to look at this first group, and in the numbers, nothing can come out between 2 and 7. But with the variables, they have an x in common. So I'm going to take an x out. I have 2y minus 7. Over here, I can take a 5 out. 2y minus 7. So this is our normal, what happens when we factor by grouping. All right? Now, if you look at example 5, though, you can also potentially have special cases when you factor by grouping. So look then at example 5. Problems once you're done. You may actually have to continue, and you may not be done when you've just factored that first way. So I'm going to group the first 2, group the second 2. I grouped behind a negative, so I need to change the sign. And then I'm going to look between these. 2 and 5 doesn't have anything, but I can pull a y squared out. I have 2y plus 5. When I group over here, 8 and 20 have a 4 in common. I have 2y plus 5. All right? 2y plus 5 is what I have in common. Y squared minus 4 is what I have left over. And so this is a factor by grouping, and I'm not done yet. So I'm not finished yet, because when I did this one, I ended up with a special case still in my terms here. And so you're not done if it tells you to factor completely. This one, I can't factor anymore, so it's going to stay the same. But this one right here is a special case. I have x squared and 4, and I am subtracting. That is a difference of 2 squares. So I'm going to say, well, the square root of y squared is y. The square root of 4 is 2. So I'm going to say y plus 2, y minus 2. And that is factored completely. And so sometimes with grouping, it's going to just stop. But anytime you have those higher exponents and you're left with like an x squared or an x to the 4th or something like that in your 2 terms, then you need to check and make sure, is this something I can keep going with? All right. The first factor by grouping didn't have any perfect squares. This one did. And so we needed to look to see if we could keep going. So I want you to try a couple of those.